AP Statistics, we have arrived at conditional probability. It is magical. You're going to love it. All right, so if you'll notice here, I've got this written out, P of A given B. That is how you read that. So you read it as the probability. My pen is a little chunky here. Okay, so this is read as the probability of A given B. All right, so that symbol means that. So the probability of A given B. That is just a math symbol. Another word that you can use in place of given is if. All right, so it can also mean the probability of A if B. So this just means conditional because if you'll think about what conditional love is, I'll love you if, all right? So I'm looking for the probability of something if something else has occurred. So that is what conditional probability is going to look like. So as an example, I want you to think of it this way. In general, let's say I have an AP Stat class of 27 students. And let's say that of those students, I've got a certain number of males and a certain number of females. So let's say for my males, I have a total of 12. And for the females, I have a total of 15. So there's my 27 students all accounted for. And let's say I want to find the probability based on an extracurricular activity that they may or may not be involved in. So let's say I'm interested in choir. Okay, I was in choir, so we're going to go choir or no choir. All right, and of the males, I find that 3 of them are in choir and 9 of them are not. And of the females, I find that 7 are in choir and 8 are not. So if you'll notice this, I'm going to add these together here so we know all of our totals. So if I'm looking at a table of information here and I want to find a conditional probability, let's say I want to know the probability that someone's in choir given they are a female. All right, so if I was just asking you the probability of someone being a female and in choir, okay, so the probability of female and in choir, that would just be 7 over 27. Okay, because the intersection of choir and female is 7 in my table. But when I'm asking you a conditional probability, it means now I'm narrowing my population of interest, in this case, these 27 people in this class. I'm narrowing it down to some of them. So I want to know the probability someone's in choir if I know they're a female. So now, rather than looking at all 27 people, like I did for the probability of female and in choir, now I'm just interested in these people right here. So now, given they're a female, now I'm only taking it out of the population of females in this class, and this would be 7 over 15. So a good practice to think about here with your conditional probabilities, I like to tell my students that this line acts as their fraction line, and you just picture this just turned over. All right, so I try to show that to them that way. All right, having said that, why do we need conditional probability? What's the point? Well, we use conditional probability to explain if two events are independent formally. Remember when we first talked about the notes, I told you that independence meant that one event did not affect the outcome of another event, but I told you there would be a formal way to show that. And by formal, I mean there's a mathematical way to show that. So the way we are going to look at this, you have to think of it this way. I have my 2 events, A and B. They're both positive probability. They are independent if the probability of A given B, or A if B, equals the probability of A. In other words, if A and B are independent of one another, B has no bearing on it whatsoever. The other way to think of it, that's where the or should go right here. I don't know why it's way over there. All right, the other way to think about it is the probability of A given B equal to the probability of A not B. So they mean the same thing. Students, I think, have an easier time understanding this one right here because it looks the same as it does on the left. So the probability of A given B should equal the probability of A not B if they're independent. Now, if you find that they are not equal to each other, that means they're not independent. So, of course, we are going to look at some examples to help you understand these two ideas a little bit better. The reason I talked about conditional probability and independence in the same video is because, as you can see, the conditional setup is part of proving independent events in a formal math situation. So now I'm going to move on to some examples, so hold tight.